It's time to take 5 for safety. It's time for another episode of Let's Not Die Today on the Toolbox Talk Show Network.
Hey everyone, as always, do me a huge favor and click on that little subscribe button wherever you get your podcast. And don't forget about our friends over at 7Taps. They make micro-learning easy. Go to 7taps.com, get the free community version. Try it out. You have to experience it. It's the absolute best way. You're going to love it. And when you do, buy the pro version. But before you upgrade, go to toolboxtalkshow.com/training and get all the bonuses just for being a listener of this show. All right, our topic today is industrial compressed gases. Compressed gases can be extremely dangerous, as we will see when discussing actual events in today's episode. Also, we will cover ways to stay safe when working with industrial compressed gases. Let's start with definitions. Industrial gases are gases manufactured for use in industry. Industrial gases can include nitrogen, oxygen, carbon dioxide, argon, hydrogen, helium, and acetylene. Compressed gases are those stored under pressure in cylinders. The pressure in a gas cylinder is usually recorded as pounds per square inch. The 3 major types of gases include compressed, liquefied, non-liquefied, and dissolved. Let's talk history. The history of industrial gases is the history of chemistry. In ancient Greece, many philosophers believed that there were 4 basic elements: earth, water, air, and fire. Today, we recognize these as states of matter, including solid, liquid, gas, and plasma. Around 300 BC, Greek philosophy and Egyptian meteorological tradition intersected, creating alchemy. Alchemy erroneously theorized the philosopher's stone, a substance that could transmute metals, transforming metals such as iron or lead into gold. Late in the 17th century, many scientists began experimenting with gases. The increased interest in gases led to the development of pneumatic chemistry. In the 18th century, the Industrial Revolution propelled science even further. Many gases were identified and either discovered or first made in mostly pure form. The collaboration between chemists and industrialists proved crucial in commercializing industrial gas. In 1754, a Dutch chemistry teacher discovered carbon dioxide. In 1766, Henry Cavendish discovered hydrogen, but didn't know it at the time. In 1781, Cavendish found that he could create water by combining hydrogen and oxygen. Only years later would hydrogen have a proper place in chemistry and get its official name, which means producing water. In 1844, nitrous oxide was first used for dentistry. Initially used for lighting and welding, acetylene would launch the industrial gas business. By the 19th century, gases had found uses in food, refrigeration, medicine, fuel, lighting, fertilizers, fire extinguishers, fizzy drinks, Coca-Cola uses carbonated water, and even flight, the Hindenburg. Today, industrial gases are used in a wide range of industries such as oil and gas, power, chemicals, mining, steelmaking, metals, pharmaceuticals, biotech, electronics, and aerospace. Let's talk statistics. According to the Bureau of Labor Statistics, there were 10 deaths and 3,920 injuries related to pressurized containers in 2016. For this episode, statistics on industrial compressed gases were challenging to find, but OSHA has information on specific incidents, and I thought we could go through several of them. In December of 2021, an employee attempted to light a pilot of a propane gas-powered oil fryer. The employee went to find a lighter, but left the gas on. Returning 8 minutes later, she attempted to light the pilot, and the gas exploded. The employee escaped, but was hospitalized to treat burns to her face, arms, and chest. In December 2020, an employee was cleaning deer hides with a gas-powered pressure washer in a skinning room. The next day, the employee was found lying on the ground with the room's door closed. The employee died due to carbon monoxide asphyxiation. In March 2018, an employee moved a cylinder using a cart. The cart fell over and crushed the employee's finger. His fingertip was later amputated. October 2017, an employee was using a torch. The torch went out, and the employee attempted to relight it using an improper technique. This caused a blowback of fire, and the employee sustained burns to his arms. Let's talk safety. Safety tip number 1, safe handling and use. Compressed gases must be handled and used only by trained employees. Always consult the gas manufacturer's safety data sheets for specific information. Safety tip number 2, clearly identify cylinders. Labels must not be defaced or removed. Do not accept or use containers whose content labels are not legible. Do not use the container's color to identify the cylinder's content. Do not repaint containers. Clearly label all gas lines leading from a compressed gas supply. Safety tip number 3, valve protection caps. Leave valve protection caps in place until cylinders are secured and connected. Keep cylinder valves closed except when the cylinder is being used. Closing the valve prevents corrosion and contamination. When opening a cylinder valve, ensure it is pointed away from yourself and others. Slowly open the valve. Safety tip number 4, tampering. Never tamper with or alter cylinders, valves, or safety relief devices. Safety tip number 5, transporting cylinders. Do not drag or slide cylinders. Do not lift cylinders by the caps. Secure the cylinder and move it with a hand truck, lift truck, or crane with a cradle or platform. Do not use lifting magnets. Slings, ropes, or chains are acceptable if cylinders are equipped with lifting attachments. Never drop cylinders or strike them against one another or other surfaces. Safety tip number 6, secure and store cylinders properly. The gas inside an oxygen cylinder is compressed to 2,200 pounds per square inch, PSI. Yet the wall thickness of this cylinder is only 1/4 of an inch. If the cylinder falls over and the valve breaks, the gas will escape through an opening about the size of a pencil. This minor incident will turn that gas cylinder into a rocket, which will go through walls, ricochet, spin, and damage anything in its path. So always secure gas cylinders to avoid tip over. Group and store compressed gases based on their hazard class. Provide adequate space or segregate by partitions. Post conspicuous signs that identify the gas or hazard class. Store full and empty cylinders apart. Always handle empty cylinders as though they are full. Storage areas should be dry, well-drained, ventilated, and fire-resistant. Cylinders can be stored in the open, but they should be protected from rusting. Prevent exposure to salt, corrosive chemicals, or fumes. Cylinders stored in the sun must not exceed temperatures above 125 degrees Fahrenheit. Always refer to the manufacturer's storage requirements and SDSs. Storage areas should protect cylinders from damage. Do not store on unprotected platform edges or obstruct walkways or exits. Safety tip number 7, inspect cylinders. Inspect for exterior corrosion, denting, bulging, gouges, or digs. Leaking regulators, cylinder valves, or other faulty equipment should be taken out of service. Return questionable cylinders to the gas supplier. Safety tip number 8, know the dangers of compressed gases. The primary hazard for acetylene and propane is flammability. Both are secondarily asphyxiants. Argon and carbon dioxide are asphyxiants. Asphyxiants, including inert gas, can displace oxygen and may cause suffocation. Corrosive and toxic gases present serious hazards. Keep exposures as low as possible and avoid inhaling or contact with skin or eyes. Safety tip number 9, assess your shop. Look around. Are gas cylinders stored properly? Are valve protection caps in place? Are all gas cylinders secured to prevent tip over? Are cylinders properly segregated? Empty or full and by type? Safety tip number 10, fuel gas and oxygen cylinders. Acetylene is a gas that is almost universally used for welding. When mixed with oxygen, acetylene burns at temperatures exceeding 5,000 degrees Fahrenheit. Always store acetylene cylinders and any fuel gas cylinders at least 20 feet from oxygen cylinders. Suppose 20 foot of separation is impossible. In that case, gases should be separated by a 5-foot minimum, non-combustible, half-hour rated partition, such as a metal barrier. Following these tips can save you from accidents, injuries, and even death. Thanks for listening to another episode of Let's Not Die Today. If you'd like free PDF versions of all our talks, please go to our homepage, scroll down about halfway, and sign up for our mailing list. As always, you can find us on Spotify, Apple Podcasts, and YouTube. Please subscribe. Oh yeah, and please tell your employer about us. We'll love you for it. See you next time.